10-3 covers measures of center. I believe that's also known as measures of central tendency, and if it is what I think it's going to be, this is going to be a straight-up review for you. The textbook says this is a 3-day lesson. I'm thinking it's probably going to be a 2-day lesson. We have 17 resources to get through on it, so let's get started and see where it takes us. They want us to start off by exploring their infographic they have here, and they say describe a real-world situation where you might compare the center of two data sets. And it says the countries that compete in international soccer competition field teams using the nation's best players. The teams compete against other countries' teams in tournaments, the Olympics, and the World Cup, which is a really big deal in the soccer world if you like watching people with really high socks run around on a cow pasture. How can you compare your team to other countries? How can you use statistics to determine who will come out on top? These are all parts of the measures of central tendency that we're going to look at. So we're going to say, let's see, measures of center represent the center of data using a single data value. There are two measures of center that are used to represent numerical data sets, that is the mean and the median. Your mean is going to be the average of your data set. Think about it, that mean old math teacher gave you a bad average. The mean means the average, and it's found by dividing the sum of the data. That means you add all the data pieces by the number of data values. So for example, to find the mean, right here it says add the total number of goals scored by each team and then divide by the total number of games. So you would add up all of the US's team goals, which were 63, and divide that by 19 games. You would add all of Japan's scores up, which is 33, divide by 19, which is the number of games they had, and you could see that the United States averaged 3.3 points per game, while the Japanese girls team or women's team averaged 1.7 goals per game. Now your median is a totally different data value. When we're talking about the median, we're talking about the middle data value when all the data values are arranged in order from least to greatest, or really from greatest to least. It doesn't really matter. So take the women's soccer team down here. When you took all the data values they had, rearrange them from least to greatest, the one that was in the very middle, that was going to be the median. The median ended up being 2. Sometimes the data set is made up of non-numeric data, and when that's the case, it's best to use the mode, or the one that occurs the most often. The mode is used for categorical data and is a value that occurs most often. For example, right here you can see your shirt sizes where you have extra small, small, medium, large, extra large, 2X and 3X for our soccer jerseys. And which one is the one that occurs the most often? Well, that's going to be the mediums that you see right here. The mode is the one that occurs most often. Moving forward, data set can contain many values, but sometimes it is beneficial to find a single value that can represent or summarize the entirety of the data set. Measures of center, also known as measures of central tendency, are numbers used to describe the center of a numerical data set. Vocab word, highlight it. The measure of center that you will learn about in this lesson is going to be the mean and the median. One measure center used to describe a numerical data set is going to be the mean. Now that's not the actual definition of it, but it's one that is. The mean, here is your definition. The mean is going to be the average of the data set and can be visualized using the data in a sense of fair share. That's a new term for me, fair share. If all the data values are totaled and then distributed evenly or fairly, each quantity or category will get its fair share of data sets at the same amount. The number that represents its fair share is the mean of the data set. So what they're saying is they want to take and average out the number of books, or find the mean of the number of books that all the students read, and then distribute them evenly so that each student gets their fair share of books to read. I don't think that's right, but hey, that's not my decision to make, I guess. The first thing they want us to do is drag the X for the line plot to distribute to evenly distribute the books for each student. So we're going to start off with, Mara had 2 books. Next we've got Ty, and Ty has 4 books. Ty's just a little book hog, isn't he? And then from there we got Ellie, who only had 1 book. Actually that's not Ellie's color, this is Ellie's color. And then you have Sam, got the light blue. Sammy's got 2 books. And then finally Lee. Lee has 1 book. But did we distribute them evenly to each student? We did not. Right now we're showing the number of books that they each read, but to distribute them evenly, old Ty here, he's going to have to share some of his books. So now we have an average or a mean of 2, where each student reads 2 books. Ty might not be too keen on the idea of giving up some of his books, but we don't really care because he doesn't deserve all those books. Yeah, right, whatever. Continuing on, the textbook tells us that if the students' total number of books they had and then distributed them evenly, each student would have 2 books. That's the average of the books or the mean of the books. By redistributing or leveling out the data, each student will have a fair share of the total as shown in the line plot. The fair share or mean, which is going to end up being 2 books. Now the mean as a fair share demonstrates the mathematical formula used to find the mean of the data set. The mean of the data set is the sum of the data divided by the number of data values. And we're going to highlight that because that explains what's going on down here. You can find the mean number of the books by adding the number of books in each set and then dividing that total by the number of people reading, which was 5. So we had 2 plus 4 plus 1 plus 2 plus 1, which ended up giving us a total of 10. 10 divided by 5 was 2, which means the mean or the fair share of number of books for everybody is going to be 2 books. And this takes us into example 1 that says the student council is creating a multicolored balloon arrangement to display on the stage at the sports banquet. They want to create 4 arrangements with each arrangement having the same number of balloons, but not necessarily the same colors. The table shows the number of each color of balloon that they have. Find the mean number of balloons to summarize the data, and that means that every table will have their fair share of balloons to go in the arrangements. So what do we need to do? Well, let's see what they want us to do. You can use fair share to distribute evenly, and distributing evenly means that we would take and just drag and drop. Everybody gets 1 balloon, and then we're going to do everybody gets 2 balloons. This is so slow. I sure do wish I could use algebra for this. Algebra would be just so much easier. And boom, you can see that the fair share or the mean would be 5, where each arrangement would have 5 balloons. Doesn't matter what color they are, they all have 5 balloons. Now method 2 is totally the way I would do this. I'd be using the formula to find the mean, where we take the sum of the data values divided by the number of the data values. What does that mean? Well, let me get my camera thing out of my way here. That means that, whoops, push the wrong button here. We're going to take and add up the data values, which is 2 plus 8 plus 6 plus 4, and divide it by the number of tables or number of arrangements we want. From there, you add them together, you get 20 divided by 4, which means that there's going to be 5 balloons in each set, just like we found the other way when we were taking and dividing them up all by the number of arrangements, 1 balloon at a time. This is the kind of supporting work that I'm going to be looking for on your homework, where you've given me a formula, you've given me supporting work on where you put your values in, you added them, and then you divided them. And now it's going to be time for you to pause the video and work on this example, extra example 1, using good big kid algebraic supporting work. Let's take a look at it. A bakery donates any baked goods remaining at the end of the business day to a local volunteer organization. They package the items 5 to a bag. with each bag having the same number of items, but not necessarily the same types of baked goods. On a given day, the bakery had 14 bagels, 6 muffins, 8 croissants, and 3 cinnamon rolls, and 4 loaves of bread. Find the mean number of baked goods in each bag to summarize the data. Well, what we're going to do is we're going to start off with a formula, and boom, there's my formula. Next, which says the mean is equal to the sum of the data divided by the number of data. That means that the mean is going to equal to my sum of my data, where I've got 14 bagels plus 6 muffins plus 8 croissants plus 3 cinnamon rolls plus 4 loaves of bread, divided by how many bags do they have? 5 bags that they're going to be going to. 14 plus 6 is going to be 20. That's going to be 28, 31, 35. So now my mean is going to equal to 35 divided by 5, also known as 7. So each bag is going to end up having 7 items in it. This is a supporting work that you need to have to go with this problem while you're doing your homework at night. I've got a formula. I've got the where I plugged my data values in. I simplified and I simplified more to get the final answer, which we're going to put right here. This says 7. Check our answer. Easy math. But what if our textbook gives us a set of data that's incomplete, and they also tell us what the mean or the average is going to be? How could we find the missing data piece? That's going to step up our game just a little bit. The number of photos Alex took on her phone for 5 days are going to be 12, 23, 8, 15, and 3. So there's 5 days in the number that are out there. Suppose the mean for the photos for 6 days is going to be 11 photos. So out of the 6 days she was there, she had 11 photos. We know that what 5 of the days are, we have to figure out what it's going to be, the number of photos would be on the last day, so that there is going to be an average or a mean of 11 every day of the week. Let's see how they want us to approach this. Method 1 says draw a model to represent the number of photos taken each day, and you can see here that you've got a total of 11 for day 1, day 2, day 3, day 4, day 5, and then that means day 6 would end up having a total of, let's see, they've already added the values of what they had. So what they came up with is they had all the different days averaged out here, and how many more X's do you need to get to 11 here? Well, you would need, let's see if they want us to do it like this. 1, 2, 3, probably a space between them, 4 and 5 X's, I think, is what they want us to do, which means that there would be 5 photos that were taken on the 6th day. Let's see if that worked. Hey, I even showed my work the right way, and that was just a random guess on how they wanted it. For method 2, our textbook is going to take and use the equation, and in this equation they're going to start off with a bar diagram, where they took and added up the data values they had, and they said that when they added up the 5 days that they knew about, they knew they had a total of 61 images taken. We also knew that there was a total overall of 66 images taken. The way they did that is they took the and multiplied the 11 by the 6 days, and that gave them 66, because remember we had an average of 11 photos, and 11 photos times 6 days gave you the 66, and that explains the bar diagram here. A total of 66 photos is equal to the 61 photos we know about, plus M being the photos that Alex took on that 6th day. And that comes down and gives us the equation that says 61 plus M is going to equal to 66. The missing value, well, let's be big kids and do this using big kid math. So we're going to take and plug it in. 61 plus M is equal to 66. Yes, I know you can do this in your head, but you still have to have big kid supporting work. Subtract 61 on both sides. When you do that, those zero out, leaving M is equal to 5. So once again, we have the same answer where the number of photos, the missing value is going to be 5 photos. In either method you took, he used 5 photos, took 5 photos on the 6th day. Now that is where we're going to stop video 1, come back and watch video 2 where we continue our study into using measures of center or measures of central tendency. I'll see you in video 2.